That, like I said, I was going to. So a rhombus, key thing with a rhombus, all four sides are congruent. Key things with a square, all four sides are congruent. So it's a rhombus, but it's also a what?
It's got all four right angles.
It's got all four right angles, which makes it a, it's a rectangle. So it's a rectangle and a rhombus, which together make a square. Good. I'll tell you what, I'm going to go ahead and draw. Is a rhombus a parallelogram? Yes. All right, and you can tell from the chart here, right? Parallelogram, offshoot is a rhombus. The other offshoot's a rectangle. So yes, it is a parallelogram. If you draw, if I draw the diagonals in here, we sort of went over this last time, if I can draw straight. The only new properties a rhombus has that wasn't the properties of a parallelogram are, number one, all four sides are congruent. And we just talked about that. The other thing is, what looks to be true about these angles in here?
They're right angles.
They're right angles. All right, all four of those are right angles. So what kind of triangles do we have? What kind of triangles are all four of those triangles? One word, the easy one. They're right triangles, thank you. And if they're right triangles, then we can do stuff like sine, cosine, tangent, Pythagorean's theorem, all that stuff with them, right? Sorry, I could tell you guys were thinking I was looking for some harder name, right? They're just right triangles. We know that they're all right triangles. The other thing the diagonals do, if I could draw straight, what looks to be true about these two angles? They're congruent to each other. With a parallelogram, what did you know about opposite angles? They were congruent. So if these two down here are congruent, what do you know about these two up here? They're congruent. So all four of these angles are all four marked the same. Guess what's true about all four of these others over here? They're all the same also. So if I told you one of these angles, if I told you this angle right here was, let's say this one. Get rid of that. Come on, get rid of that. If I told you that angle was 30 degrees, what would this angle right here have to be? 30. Now my picture doesn't look like this, so it's all messed up. These are 30. These are 30. What would these two have to be? 60 and 60. 60 and 60. And then Brian already said, what kind of triangles are these in? 30, 60, 90. And we're going to talk about 30, 60, 90, and 45, 45, 90 triangles again. And we'll write that down here in a few minutes. Some of this. All right, properties of a rhombus. It's got all the properties of a parallelogram. Also, these next three are the properties that are new for a rhombus. So these three are new for a rhombus. All the sides are congruent. Diagonals are perpendicular. Diagonals bisect the angles. Those are the ones we just talked about. Write this down. That's where we got left off last time. Is that right?
Yeah, we're writing it down.
Also have your calculators laying out so I can check them. Probably gonna check calculators every day for the next couple of weeks. So make sure, start bringing them every day, have them laying out each day. Do me a favor, hold your calculator up there so I don't have to walk around. Got one in there, Dustin? I got it. Old Riley back here acts like it just killed her to hold her arm up in the air like that. She's gonna die. So we went over all these. Rhombus has all the properties of a parallelogram because it's an offshoot of a parallelogram. All the sides are congruent. Diagonals are perpendicular to each other. What's perpendicular mean again?
Intersect their teeth.
All right, so that give me 90 degrees or
Both opposites.
right angles, right? 90 degree or right angle, that's what perpendicular means. Diagonals bisect the angles. What's it mean to bisect the angle?
Just split into two congruent segments.
Split, not segments,
Angles.
two congruent angles. Now, to prove something is a rhombus. To prove something is a rhombus. Easiest way, first thing you got to do, well, the very first thing is, it has to be a what? Got to be a quadrilateral. Can everybody, how do you tell if something's a quadrilateral? It's got four sides. You just count, right? Then you got to check to see if it's a parallelogram. If it is a parallelogram, then it might be a rhombus. And the easiest way to prove something is a rhombus, if the diagonals are perpendicular, so if the diagonals form right angles, then it's going to be a rhombus. Now looking at our chart here, if it is a rhombus, is that the very best name to give to it? You don't know. And what you need to do, and we're going to talk about that here in a minute, what you need to do then is check to see if it's a rectangle. Because if it's both a rhombus and a rectangle, then guess what you know about it? It's a square. Getting all this? I'm recording now, or I'd say my saying right now that I said was going to be the saying I was going to say for the rest of the year over and over again. I'm not going to say that since I'm recording. All right, is the square a parallelogram?
Yes.
Looking at a chart, square parallelogram? Yeah. Is the square a rhombus?
Could be.
Yeah. Is the square a rectangle? Yeah. It's actually all those. So guess what the properties of a square are? All the properties of a rhombus, properties of a rectangle, and properties of a... Alright, properties of a square. Instead of having me write all these out, I was a little nicer this time. Just write down those three things that we just said. Square has all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. Now you got to remember what those properties are, or be able to refer back to your notes, which we wrote down last 2 or 3 or 4 times, however many times it's been. Now we're actually going to add one more to this. So I'm going to write it up here, number 4. We'll write it down here in a second. Everybody got all three of those memorized, so I can go back a slide? If I draw the diagonals in a square, we just said on that previous slide that a square is a rectangle and it's a rhombus. Well, if it's a rhombus, what do you know about all four of these angles here in the middle? They're all congruent. Not only are they congruent, what else do you know about them? They're all right angles. So each one of those is a right angle. So again, with the square, all these little triangles are right triangles. Now these triangles, unlike with just a rhombus, with a square, they're actually special triangles. What can you tell me about this whole angle over here? What was it, if that's a square? That whole angle, this whole thing. It's 90 degrees. Good. The diagonals in a rhombus bisect the angles. So what do you know about each of these two angles? They're the same. How much are they? Grab your calculator. That's why I had you get them out. They're each 45. How about these two angles down here? They're each 45. How about these two angles? 45. How about these two? 45. What kind of triangle is all four of these triangles? It's not just a right triangle now, it's a 45, 45, 90 triangle. In a 45, 45, 90 triangle, if I split this 45, 45, 90 triangle off one of them, I'm hoping that you remember the sides across from the 45-degree angles were labeled good, and the side across from the right angle, L radical 2, good. L times the square root of 2. And that's what we're going to put. I just felt sorry for a square, because a square doesn't have anything of its own. Like you, right, Jonathan? Don't have anything of your own. Got hand-me-down clothes from your sister and stuff, right? So square doesn't have anything of its own. So just to at least give it one property, in a square, the diagonals form 45, 45, 90 triangles. So write that down. I'm going to draw the picture of a 45, 45, 90 triangle over here and relabel it so that you can have it right there in your notes instead of have to refer way back to when we were doing that. In a 45, 45, 90 triangle, you guys just told me the sides across from the 45-degree angles are L, side across from the right angle is L times the square root of 2, L radical 2. That way you have it right there in your notes instead of have to refer way back to it somewhere else. So with that, when I draw just one diagonal in a square, what do you still know about these two triangles? They're still what? They're still 45, 45, 90 triangles. Well, if I tell you the length of one of these sides, let's say I tell you this side up here is 8. What do you know about this side down here? 8. How about this side? 8. How about this side? How about the diagonal? It's across from the right angle, right? Well, in this case, what's L equal? It equals 8. Equals the length of the side of the square, doesn't it? So how long is that diagonal? Right there, you replace L with what? 8. Don't punch it in your calculator. 1 second. It's just 8 radical 2. Yes?
Yes, Justine, Shelley.
Yes?
Could you come down to sign out, please?
Sure.
No one wants
Justine, you probably have to stop by tomorrow and you get the assignment or get it off somebody else tonight or whatever. It'll be 2 different pages. What if I give you this? What if I give you that? That's a square and that side's 10. How long is that diagonal? 10 radical 2. What if I give you this square? Everybody watching, I guarantee there's one of these on the next test. I give you this square and I tell you this side's 4. How long is that diagonal? 4 radical 2. Give you this square. Tell you the length of this side is 7. 7 radical 2 is the length of the diagonal. What if I turn it around and did something like this? Told you the length of that diagonal there was 6 times the square root of 2. How long is that side right there? 6. How long is this side? 6. So on, so on, so on. Alright? So it's just one quick thing that you know. Baseball diamond. A baseball shouldn't even be called a diamond. It should be called a what? Square. How long is the distance from home plate to first base? How about?
90.
Now, if we look at this, that would be a diagonal, right? That's the catcher wanting to throw down the second. That's how far you have to throw. Guess how long that is? 90 times the square root of 2. Now, probably if you're going to go out and actually try to measure it on the baseball field, you probably don't want it 90 radical 2. Then you'd want to grab your calculator and change it into a regular number, feet and inches. All right, to prove something is a square. Way you need to prove something is a square is you're going down through this chart. You prove it's quadrilateral. You prove it's a parallelogram. You go to rectangle. You prove it's a rectangle. Do you just stop there and say it's a rectangle? No. Jump over here to rhombus and you check to see if it's a rhombus. If it ends up being both of those, then the very best name you can give it is a square. So to prove it's a square, you've got to prove it's a rectangle, then prove it is a rhombus. Doesn't really have its own way to prove something is a square. You got to prove it's these two things, and if it's both of them, then we know it's a square. All right, the assignment. 434, write this down. Again, we're going to go around the room. I'm going to let Jonathan choose. Jonathan, do you want to start on your side of the room or the other side of the room?
You and
Other side. There you go.
You've been better off start on your side.
Yeah.
Where's the easier problems on a math assignment?
Getting started.
The beginning.
Oh, good.
So we're going to go around the room. We'll start with Clayton. He's going to work problem 12 up here on the board. Problem 13. We'll just go right down the rows. Now, as Clayton's up here doing problem 12, should everybody be paying attention up here? Yeah, because Clayton's going to come up here and he's going to draw. He's going to draw. He's going to draw the picture for the first one. Maybe it looks something like this. Do we want Clayton just to come up here and say, oh yeah, I know if this side is 5, then this side over here has got to be 5 and he's done? No, if he's writing the problem down, he should go ahead and label everything. And then you guys can help him go through and say, hey, that other angle over there is 32 degrees. This other angle is 85 degrees, so on and so on. And the more we get labeled while he's up here drawing the picture and everything, the better off for everybody who comes up next, right?